जी सलाम वालेकुम सर।
अब मेरी बात सुन रहे हैं? आवाज सुन रहे हैं? सही आवाज
जी
आ
जी
रही है?
सर। जी जी सर, आवाज़ आ रही है।
थैंक यू। बिस्मिल्लाहिर्रहमानिर्रहीम। Dear faculty members and research scholars, Assalamu alaikum. I welcome all the participants in our two-day seminar on behalf of Directorate of Advanced Studies. The seminar series is part of Decimate calendars and is carried out on every Thursday at 2 p.m. Today, the topic of our seminar is the fade-away effect of the initial non-response bias of the regression estimators in panel surveys. And it is presented by Dr. Musra Khan, Assistant Professor, Department of Mathematics and Statistics. I hope this scientific talk will provide an opportunity to get in-depth knowledge on the topic. After the presentation, there will be the question answer section. Over to Dr. Musra Khan. Please come on. We'll start.
जी सर, स्टार्ट कर लूँ?
Yes, start.
जी, बिस्मिल्लाहिर्रहमानिर्रहीम। First of all, I would like to thank Director Advanced Study for giving me the opportunity to present my research work. And the title of my presentation is the fade-away phenomena of initial non-response bias in panel survey. So before discussing the outline of the study, I would like to discuss that what is meant by the fade-away effect and what is meant by non-response in survey. So in practice, almost every survey suffers from a substantial non-response. The problem of non-response mainly arises due to refusal of the person to respond, and of course, there are many other reasons where respondent does not respond accurately. There may be some sensitivity of the question, or they are not willing to cooperate in further part of the survey. But in this presentation, we are mainly concerned with the problem of non-response in panel survey. Like in any non-mandatory survey, a panel survey suffers from a substantial non-response at its start. For example, 30 to 70% of the initial sample person refuse to participate. The motivation of this and causation of this behavior is not different from standard cross-sectional survey. While in a panel survey, since the respondent are interviewed repeatedly in later waves, or we can say in later time period, with this repeated measurement, it is possible to analyze the gross change, that is individual change. For example, poverty and non-poverty. For example, if you don't have a job and after some time period you get a job. Like in Germany, if you don't have a job, the state is paying to you some amount. So this change has substantial effect on your variable of interest. And since this has a substantial interest on the variable of interest, with this individual changes have a substantial effect on the variable of interest. As a consequence, an initial non-response bias arises from refusal, fade away in later panel waves. So the motivation, first I will discuss the motivation in more detail, that what is the motivation of the fade effect. And then this work is divided into two parts: a simulation framework, where we will compare this cross-sectional OIDS estimator and inverse probability weighted estimator. In the second part, we will use panel estimator, and in the empirical part, we will use this German socioeconomic panel income data. And last, we will discuss our results. So as I told you that there are many reasons of non-responses. There may be some invalid addresses. अगर हम selection करें via register survey, अगर हम register survey को सामने रखें तो invalid addresses की वजह से भी काफी लोग response नहीं कर पा रहे होते. No contact, unable to respond, या कुछ लोग बाद में cooperate नहीं करते. अगर हमारे पास panel data कुछ stages पे वो response कर लेते, but in some ways they are not interested to cooperate, so they leave the panel. There are some other topics, for example, sensitive topics, abortion, divorce, and the use of illegal drugs. So if the questions, yeah, you can say the question of the questionnaires are sensitive, then most of the people will either notice, provide, they will not respond, or if they provide some response, their response will not be accurate. So in the presence of non-response, it not only reduce the sample size, it does not only reduce the case number, but it also distort the distribution of the sample data, for example, from normal to non-normal, and it can also provide large bias and large variances. So it was the first finding of SIS2 that these distortion arises from initial non-response bias reduces and later waves of the panel survey. She did it for this income quintile, and she used registered data of the German socioeconomic panel data. So the basic idea of the fatal effect is that suppose we have a large population, or you can say that we have a big sample, and we impose a condition, or you can say that the sample consists of respondent and non-respondent. So in this large sample, or you can say in the population, both the respondent and the non-respondent are present. And we can here we are talking about the register data. For the non-respondent part, we can get their information from some register surveys. So suppose at the start of the survey, we are asking from individual that if you are agree in this survey, then participate. If you are not agree in the survey, then you can leave the survey. So the motivation is that in the population, we have both a respondent and non-respondent. Since the population or this big sample consists of both the respondent and non-respondent, so we assume that there will be no bias, or you can say the estimate are unbiased. Okay, and then those who participate in the first wave, like we have suppose a sample of 100 people, and out of these 100, only 70 people are respondent participate. Then these we will consider the responses of these 70 students and later waves of the panel survey. So we call that sample as the respondent sample. So the respondent sample consists of only the respondents, those who are interested in the survey. And you see that this variable YIT is equal to 1. This is the variable of interest in the start of the survey, or you can say that this is the variable of interest in the first wave. T is equal to 1, or you can say that we have initial wave. So wave and T time period are both equal. So here we have initial distribution of the variable of interest, and it is very biased with respect to response. Also, at this variable of interest, which is YIT, IT stands for wave. When T is equal to 1, we have the distribution of the variable at the start of the survey. When T is equal to 2, we have the variable of interest in the second wave, and so on. This variable of interest changes over time. Further, if there is no attrition, further we assume that attrition from wave 1 and 2 and other waves are ignorable. We can there will be some small attrition. Attrition means that when some people participate in the start of the survey, but in later waves they refuse to participate, or you can say that they temporarily leave this survey. So we assume that attrition will be smaller. Then under these expect the distorting effect of initial non-response on the distribution of variable of interest, which is why IIT has faded away in later panel waves. Like in the start of the survey, the variable of interest is biased, but in the later waves, like when P is equal to 2, 3, and so on, these distortion, you can say that the bias is reduces. So the variable of interest converge to this true distribution. Rental used this concept for Markov chain model, and he introduced the concept of the fadeaway effect. Here he used this register information, where the information on the non-respondent can be obtained from a register survey. We are not working on register information. So we will not discuss this so much because we will introduce this concept for the regression model. But the essential condition for this Markov chain approach is that we will get this idea from register survey. Similarly, in 2022, we extend, you can say that Alo et al. Extend this fadeaway approach to regression analysis. So this is our joint paper. So in this paper, we introduce a linear regression model. You can see that YIT is the variable of interest. I stand for the individual and T stand for the time. You can say time also equal to wave. This is AT plus BT, XIT plus EIT. AT is the intercept, BT is the slope coefficient, XIT is the independent variable, and EIT is the error term. You can say the residual term. And T start from 1 to capital T. Further, this XIT, which is the independent variable, is decomposed into two parts. XIT is equal to MI plus ZIT, where MI is the permanent component of the X and ZIT is the variable, is the time varying part of this XIT. The variance of the permanent component is kappa, and the variance of the time varying component is 1 minus kappa. Similarly, for the residual term, it is also divided in two parts, VI plus UIT. VI is the permanent component of the error residual term, and UIT is the time varying component of this residual term. And its variance is gamma sigma square. Sigma square is the overall variance of the EIT, the variance of the residual term. So if you add the variance of VI plus the variance of UIT, it will be equal to sigma square. Further, we impose some restriction that the range of kappa is between 0 to 1, and the range of gamma is also equal to is also between 0 to 1. So if there are some further concept, if the permanent component of MI is equal to 0, it means that the variable of interest, the independent variable is changing over time. And if in other situation, if we impose that the variance of the permanent component UI is that which is gamma. If gamma is 0, it means the residual term is also varying over time. So in cases where the size of the permanent component MI and the size of the permanent component VI is large, it means that the variable, the independent variable is not changing over time. And if the variance of this VI is, which is gamma, if this is there, it means the residual term is also not changing over time. So we expect that if the size of permanent component MI and the size of the permanent component VI is small, in this situation, the independent variable and the residual term are varying over time. And in this case, we can expect that there will be high fadeaway effect. That is, the initial non-response bias will be reduces over time. But if the size of the permanent component, that is MI and VI, is large enough, like if it is very strong, close to 1 in both cases, we will not expect a fadeaway effect. And in that case, you can say that if non-response is based on permanent component, these component MI and VI are the permanent components. So if non-response is related to these permanent components, we will not expect a fadeaway effect. Like if you are saying about gender, and if non-response is related to gender, that will not reduce over time. So we will check that if the size of this permanent component is small, then we will expect a high fadeaway effect. We can say that the initial non-response bias will be reduces so much over time. And in data panel, where we will expect that there will be no bias in the estimate. You can say the estimate will be unbiased. So these are some conditions. Further, for the time varying component of the X variable ZIT, we assume that it is correlated with its previous time period. For example, the income of a person at the present time period is related to his income at the previous time period. So this magnitude is denoted by rho. So if the magnitude of rho is zero, it means that the variable of interest, the current time variable, which is t, zit, is unrelated to, yeah, uncorrelated with this his previous time period. So in this case, we will also expect a high fadeaway effect. And for these parameters, we use these are variances. Similarly, the time varying component of the residual term, which is UIT, it is also linked to its previous time period, UIT minus one. So if this parameter T is small or close to zero, it means this both time period variables are uncorrelated. And in this case, we will also expect a high reduction in the non-response bias. But if these parameters like kappa, gamma, p, and if these parameters are enough, are large, we will not expect a fadeaway effect. So this is the basic idea, or you can say the statistical model. Similarly, for the initial non-response bias, we ask the respondent that if you are agree in the survey, then participate in the survey. If you are not agree, then it's up to you. So for that model, for that scenario, we introduce this response model. This RI1 is the indicator variable, and if it is equal to 1, which means that the respondent is agree to participate in the survey, and this is equal to alpha plus beta yi1. yi1 is the response variable at the start of the survey, and these alpha and beta are the non-response parameter, and you see that the response of the person depends on alpha, beta, and the variable of interest yi1. If if the response if in this model if beta is equal to 0, it means that the response will be equal to alpha, and in that case we will not expect any bias. You can say that this is the missing at random assumption. Statisticians are more favorable to that model. So if beta is equal to 0, we will not expect any bias in this in the estimate, and you can say that estimate will be unbiased. So if beta is greater than 0, then there will be some kind of bias always present in the regression estimators. So we assume that alpha and beta will be both will be greater than 0. But we will choose such value of alpha and beta so that there will be a response rate of 70%. So this is a response model, and by putting this model into the regression model, we get the bias of estimate by which is written as this in this equation. So by using the Euler's estimation method, the bias of the Euler's estimator, we are interested mainly in this beta, the slope coefficient, and by applying this Euler's estimation formula, the bias of this beta, B is equal to this one. You can see in this formula that if we put sigma square, which is the variance of the residual term, if we put the variance residual term equal to 0, then there is no bias present in the estimate. But in that case, it will be like a mathematical model. But here this is not a mathematical model. There is always some uncertainty involved. So we impose that sigma square, which is the variance of the residual term, is greater than 0. And we also impose that if beta is equal to 0, then there will be obviously no bias present in the estimates. So we also impose restriction on beta, that beta will be greater than 0, and also sigma square will be greater than 0. Under all these scenarios, we will expect that high bias, initial bias, will reduces and later panel waves. For example, here are some graphs. We introduce like a 4-wave panel. Like here you can see on the x-axis we have wave of the panel, and on y-axis we have a bias of the estimate. In the start of this survey, in the start of the initial wave, which is wave 1, you can see that for different values of the residual terms, for example, sigma square equal to 1, you see that there is an initial bias of 25%. But in just after one panel waves, the biases vanishes. So the estimate are almost unbiased, and you see in later waves there is no bias. So it also, but it does not depends on the residual values, but it also depends on the stability of the model stability of the model. For example, you see this is scenario A, and I noted it here like when kappa, gamma, rho, and p is equal to 10%. So it is very small. It means the way our regression model is changing over time. So in this case, we expect a high fadeaway effect of the non-response bias. And in the second scenario, for example, here, when the stability is medium, you see that the model is not changing so much over time. Like here we have covariance or correlation between different model parameter. You see the initial bias is fixed, that is 25% for sigma square is equal to 1, and for other parameter 20, 15, etc. But since this stability is medium, so you see that in later waves and second wave, there is a reduction. Of course, there is a reduction something like 50%, and it's reduces step by steps. In extreme scenario, when we have for example, scenario C, when these parameters are extreme, kappa, gamma, and any parameter of this is extreme, for example, 90%. So it means that later regression model does not play any role. We are providing the old parameter to the respondent. So you see that there is no reduction in initial bias. For example, for this black line, this is 25%, and second wave, it is almost 20, 22, 23%, and there is almost negligible reduction. So we will choose such parameters so that we can expect a bias. So if the stability of the parameter is small, we will expect a reduction in the bias. Otherwise, we will not expect a fadeaway effect. So this just you can say that a linear approximation formula. This is here we use a linear model for the response. But one disadvantages of this linear response model, alpha plus beta I, y is equal to 1, is that it is a probability model. And we know that probability will be always between 0 to 1. But if we have large value of y and multiply it to some positive value of beta and some alpha, so there will be some values outside this range. And you see that on y-axis we have, on x-axis we have the dependent variable, and on y-axis we have the response probability. And you see this blue line, this is the response, linear response model, and this dark red line is the other model. You can see, we will discuss it later. That is our logic model. So you see that the range of this probability is between 0 to 1, and you know that probability is always between 0, but this line goes below 0 and above 1. So this is one of the disadvantages, that this model, this linear probability model, is not appropriate or not suitable for the further research. Or you can say that if you are using this model, then you will focus so much on these alpha and beta, so that this interval, this values remain this interval. On the other hand side, if you use logic model, and we can put every value of y, for example, from minus infinity to plus infinity, you can change any value in this response, and then at result you will get a response probability between 0 and 1. So therefore, we will use for the further analysis, we will use a logic model. Sorry, light चली गई थी, इस वजह से interruption हुई है. So हम again continue कर लेते हैं. Design of the simulation study. There are many scenarios, but here we will focus on these three scenarios. Scenario A, with low stability when model parameters are less correlated, and medium stability when model parameters are medium, and extreme scenario. Then we generate an artificial data of size. Just 1 minute. So we generate artificial data from the regression model, and then we call a full sample data from all the participants from the 1 to 10. So we restrict our analysis to 10 panel waves. Usually panel waves between 5 to 10 is of reasonable size. For example, if you increase to 30, 40, which means it's a big panel, and in that case we will lose a lot of sample size. Maybe some people have died and some people left the survey, so we will restrict our survey to this 10 panel waves. So the full sample consists of all participants, meaning that it includes respondent and non-respondent as well. So there will be no bias in this full sample. Then for the non-response model, as we discussed before, that before we use a linear model, which is alpha plus beta yi, but this has some disadvantages. So here, for the initial non-response, we will use this Dodgett probability model. Dodgett probability model. So in this model, you can put every value of y and every value of alpha, beta, and as a result, you will get a probability. For example, here we choose alpha minus 4.5 and beta 3.2. And when we put these values in the model, we get a non-response rate of 35%. So non-response rate is 35% and response rate is 65%. Similarly, we use another model, which is attrition model. If there is further dropout of the initial wave. So for the attrition model, we use alpha steric, beta steric, and this YIT means when t is equal to 2. Before we use y is equal to y1 to indicate the initial the distribution of the variable of interest in this initial wave. But here we use YIT, t start from 2, 3, and maximum up to 10. So this is the attrition model, and when we select alpha steric 90% and beta steric 0.9, then the attrition rate is between 5 to 10%. And we replicate this simulation model 100 times. So we get a respondent sample. Like here we have a 100% response rate in the full sample. So if we subtract from 100% response is 35%, we will get a response rate of 65%. So that is our respondent sample, which consists of our 65% respondents. Further, here we will also compare because the purpose is to how to reduce the initial non-response bias. So for that, we will also use some weighting scenario, which we call inverse probability weighting. So inverse probability weighting, here we have many scenario, realistic cases and unrealistic cases. To control the initial non-response bias, we assign weights to the observation of the original data. Here the first wave we assign x1 as a weighting variable, which is of course a realistic scenario because usually information on the covariate is usually available for the respondent and non-respondent. You can take the information on non-respondent from a registration office, etc. So usually this information is available. But if it is not available, then and let's insist the panel data. So in data panel waves, we can use information on the lag dependent variable yt minus 1. In the second inverse probability weighting scenario, which is IPW2, Here we control for the initial non-response, but we do not control for the attrition rates. In the unrealistic case, if in worst case, if there is no information on the covariate available, here we can use a true weighting variable, which is y1. And in later waves, we use this yt minus 1. And the last scenario is this ordinary least square estimator scenario where we do not use any weights. So this is unweighted scenario. And here these are some response, these are some models. And you see that this is the wave. On x-axis we have the wave of the panel starting from wave 1 to wave 10, and on y-axis we have the bias of the estimator. And you see this green line, which is Euler's pull. So this is the bias of the estimator on the pull sample. You see there is no bias in the estimate because it's close to zero. So there is no bias on the pull sample because it consists of pull respondent and non-respondent. So there is no bias in this sample. But on the other hand side, on the other side, this red line, which indicate the bias under risk sample, where we do not use any inverse probability weighting scenario. You see the initial bias is 30%, but if in the second wave it reduces almost equal to 0. So here this is scenario A, which means that the model parameter are less correlated. So of course this is one effect is the model parameter which are low. Secondly, here we are using this inverse probability weighting scenario, and you see that this blue line, which is in IPW1 respondent sample, here we use weights by the covariate, which is x1, to reduce the non-response bias. But instead of reducing the non-response bias, it basically increase the non-response bias. This is because here we use a wrong weighting model, because if you look to this previous model, your response model depend on y, which is a variable of interest. But here we use weighting as x variable. So here we use wrong weighting model. So if we are using wrong weighting models, the bias may be overestimated, or it may be underestimated. So this is the case. On the other hand side, when we use this true weighting model, which is y, this is the unrealistic case. Weighting very help in reducing the bias. Like for other scenario, it is 30%, 35%, but for the true weighting variable, it is a 10% bias. So weighting is only beneficial if we are using the right weighting model. On the other hand side, if we are using the wrong weighting model, our estimate may be more and the bias will be more and more. Similarly, for other scenario, for medium and extreme scenario. And in the second part, we use panel model estimator. There are some models in the OLS, and there are some variable in the OLS formula which it cannot be controlled. For example, the unobserved variables is not controlled by this ordinary least square estimator. So to control the unobserved heterogeneity, we use this panel model estimator. Here, this is the pooled OLS estimator, which is just OLS, but we apply it on a panel or time series model. And this is the fixed effect or the within estimator, and the random effects model estimator. So मैं अगेन मेंशन करना चाह रहा हूँ कि ये जो हमने पहले डिस्कस किया था, जो मैथमेटिकल फार्मूले थे हमारे पास, ये फार्मूले हमने डिस्कस किया कि अगर कापा की वैल्यू जो परमानेंट कंपोनेंट्स है, द वेरिएंस ऑफ म्यू आई व्हिच इज कापा एंड द वेरिएंस ऑफ वी आई व्हिच इज गामा, अगर ये परमानेंट कंपोनेंट्स लार्ज हो तो हम पेड अवे इफेक्ट या बायस में रिडक्शन एक्सपेक्ट नहीं कर पा। अगर ये कंपोनेंट लार्ज हो तो हम हमारे पास कोई रिडक्शन नहीं होगी if these values are extremely large. बट जब हमने ये जो पैनल मॉडल्स यूज किए, ये जस्ट जो हमारे पास स्पेक्स इफेक्ट और विद इन एस्टिमेटर है, तो विद इन एस्टिमेटर बेसिकली क्या है कि ये आपको जो अनऑब्जर्व वेरिएबल्स होते हैं उनको मॉडल में इंट्रोड्यूस करा लेते हैं। और जो आप लोग चूंकि भाई ये मॉडल्स हम पैनल डेटा पे अप्लाई करते हैं, तो हम उसी मॉडल का एवरेज ले लेते हैं ओवर टाइम एवरेज लेने के बाद हम एवरेज मॉडल को सब्ट्रैक्ट करते फ्रॉम द ऑब्जर्वेशन मॉडल। तो जो वेरिएबल टाइम इनवेरिएंट होते हैं, जो टाइम के साथ वेरी नहीं कर पा रहे थे, उसका इफेक्ट रिमूव हो जाता है। तो आप लोग देख रहे हैं कि जो न्यू आई है, वेरिएंस ऑफ न्यू आई है एंड वेरिएंस ऑफ वी आई है, ये देख रहे हैं, ये जो न्यू आई है एंड वी आई है, ये टाइम इनवेरिएंट पीरियड। तो ये जो विद इन एस्टिमेटर है, विद इन एस्टिमेटर अगर हम यूज करेंगे तो इन परमानेंट कंपोनेंट का इफेक्ट रिमूव हो जाएगा फ्रॉम द मॉडल पे। एंड इन दैट केस अगर हमारे पास 30% बायस, इनिशियल बायस हो, जस्ट वन वेव में वो बायस ऑलमोस्ट क्लोज टू जीरो हो जाएगा। ठीक है, तो वो हम यहाँ पे देखना चाह रहे हैं कि क्या ऐसा है या नहीं। तो जब हमने ये है हमारे पास सिनेरियो ए, इसमें एक तो हमारे पास मॉडल पैरामीटर स्मॉल है, इस वजह से आप लोग एक वो इफेक्ट क्लियर नहीं देख पा रहे हैं। फिर भी लेकिन हमारे पास जो इनिशियल बायस है फॉर ऑयल इज 10% एंड इट इज ग्रेजुअली आफ्टर वन बाय वन पैनल वेव। द जो हमारे पास विद इन एस्टिमेटर है, वो भी हमारे पास आप लोग देख रहे हैं कि जो विद इन एस्टिमेटर है वो है हमारे पास रेन वन, रिस्क से डिनोट किया ब्लैक लाइन, वो भी हमारे पास समथिंग 10% है। लेकिन ये जो हमारा जो मेन फोकस है वो विद इन एस्टिमेटेड में, कि हमारे पास नॉन रिस्पॉन्स परमानेंट कंपोनेंट को बेस कर रहे होते हैं, तो किस तरह हम उसको रिमूव कर सकते हैं अगर हम एक सुटेबल मॉडल अप्लाई करें। लेकिन इसलिए हम यहाँ पे विद इन एस्टिमेटेड अप्लाई कर रहे हैं। विद इन एस्टिमेटेड हम तब इसलिए अप्लाई करते हैं कि ये जो परमानेंट कंपोनेंट का इफेक्ट है ये रिमूव हो जाए। अब आप लोग देख रहे हैं कि ये जो लाइन है जो ब्राउन कलर, दिस इज द इफेक्ट ऑफ दिस फिक्स इफेक्ट विद इन एस्टिमेट। आप लोग देख रहे हैं कि इसका इफेक्ट ऑलमोस्ट बहुत कम है, मतलब 50% कम हो गया फ्रॉम अदर मॉडल्स, पूल ऑयलर्स या रैंडम इफेक्ट्स मॉडल। लेकिन ये सिंपली एक तो हमारे पास मॉडल सिनेरियो पे हम सेकंड सिनेरियो पे जाते हैं जिसमें हमारे पास मॉडल सिनेरियो मीडियम हो। आप लोग देख रहे हैं कि जो ऑयल सिस्टमेटर है इसका बायस, इनिशियल बायस 22% है और ये स्टेप बाय स्टेप रिड्यूस हो रहा है, लेकिन फिर भी देयर इज ऑलवेज सम काइंड ऑफ बायस प्रेजेंट। आप लोग देख रहे हैं कि आप लोग 6 पैनल वेव दिस बायस इज ऑलमोस्ट रिमेन परमानेंट। फिर इसको हम फर्दर रिडक्शन की तरफ नहीं लेके जाए क्योंकि ये परमानेंट कंपोनेंट पे बेस कर रहा होगा, और फर्दर हम इसमें बेशक हम 10 वेव तक जाए, 100 तक जाए, ये फर्दर रिड्यूस नहीं होगा। सिमिलरली जो रैंडम इफेक्ट्स मॉडल ग्राफ है, आप लोग देखें ब्लैक लाइन से, वो रिड्यूस हो रहा है, लेकिन फिर 2-3 तक वो कांस्टेंट रहता है, 7 वेव के बाद वो कांस्टेंट है और इसका इफेक्ट कांस्टेंट रहता है। लेकिन ये जो पेक्स इफेक्ट विद इन एस्टिमेट आप लोग देख रहे हैं कि इसका इफेक्ट मीडियम स्टेबिलिटी पे भी मतलब ऑलमोस्ट जीरो है, मतलब इसने जो बाइस था वो ऑलमोस्ट जीरो है, मतलब ये एस्टिमेटेड अनबाइस है। ठीक है, हम फर्दर एक्सट्रीम सिनेरियो पे जाते हैं, सिनेरियो सी पे, जिसमें हम हमारे पास मॉडल स्टेबिलिटी एक्सट्रीम है। फॉर एग्जांपल सिनेरियो सी जिसमें कापा की वैल्यू 9.9 है, गामा की वैल्यू 9.9 एक्सेट्रा। सो आप लोग देख रहे हैं ऑयल कूल ऑयल से हम कोई एक्सपेक्ट नहीं कर रहे कि हम बाइस की वैल्यू कम, और आप लोग देख रहे हैं कि बाइस की वैल्यू कांस्टेंट है। आप लोग फर्स्ट वेव पे लेके 10 वेव पे या 100 पे भी आप लोग पूरा प्रोग्राम को एक्सटेंड करें तो इसी तरह ये नाम रैंडम इफेक्ट मॉडल एस्टिमेटर्स हम एक्सपेक्ट कर रहे हैं, बाय स्टेप रिड्यूस हो रहा है। ठीक है, लेकिन जो विद इन एस्टिमेटर आप लोग देख रहे हैं, स्टिल इन दिस एक्सट्रीम सिनेरियो देयर इज नो बायस प्रेजेंट फॉर दिस फ्लेक्स इफेक्ट विद इन एस्टिमेटर। सो अगर बायस नॉन रिस्पॉन्स रिलेट हो हमारे पास टाइम इनवेरिएंट वेरिएबल के साथ, फॉर एग्जांपल जेंडर से रिलेटेड या उन वेरिएबल से चेंज नहीं हो रहे होते टाइम के साथ, तो उस सिचुएशन में हमें विद इन एस्टिमेटर पे आना चाहिए, और उस सिचुएशन में आप लोग का एस्टिमेटर होगा वो अनबायस्ड होगा। So this within estimator is more robust if non-response is based on permanent component. Similarly, in the implication part, we use this German socioeconomic panel data. This survey started in 1984 and it's still running. And its wave is currently 39 wave. This survey started 1984 and it's still running. Every year in the start, they interviewed something like 20,000 people from more than many households in Germany. This include Germans and foreigners, and the foreigners include Turkish, Yugoslavian, Spanish, and other European people. So we restrict our analysis to these 10 panels starting from 84 to 1993. And the variable of interest is lakh hourly wages of the individual who are in the labor force, 18 from 65, and those who are working as part-time or full-time. Hourly wages are calculated by annual gross income divided by annual work hours. The regresses are age, year of education, gender, marital status, and firm size, that individual working with the company, and job tenure, that is the individual experience with the company. Similarly, due to some multiple narrative problem, age, square, and year of education are omitted from this model. And this is some summary statistic. For example, you see that hourly wages, when we are talking about the survey 1984 to 19, at that time, the hourly wage in Germany was something like 11. And this is minimum value is 11 cent, maybe some part-time job holder are there. And maximum value per hour is something like in 1984 to 1993 is something like 628 per hour wages, and there are age and other values. And these are firm size, that is individual working with a small firm, that is in a company consists of from 20 to 200 employees, 200 to 2000 employees, and more than 2000 employees. And we expect that this fadeaway effect is strong if we have variable which is varying so much over time. So hourly wages, we will see that this is changing so much over time. On the other hand, year of education, this variable, after this is changing, but after some time, this variable remain constant. Male gender is also constant. It does not change over time. So for these variable, we will not expect so much. And similarly, single, those who are single, they become married after some time. And these are other labor market variables and this job tenure. And so after all these excluding variable and some manipulation, we are in this 10 panel where we have a sample of 35,000 people. This WIT is the dark hourly wages. This is our regression model, as I already discussed: age, year of education, gender, single, firm size, etc., tenure, and other video. And this EIT is the error term. Full sample data from the German socioeconomic final data starting 1984 to 19, and this consists of this full sample consists of 3,500 employees, a person. Then for the respondent sample, we use this logit model, and we use this parameter alpha -2 and beta, this 1.5. The purpose is to make a respondent sample bias in the start of the survey. We introduce these parameters. So these parameters give us a non-response rate of 30%, which means the response rate is 70%. We replicate these results 100 times, and this the respondent sample consists of 2,500 persons. Further, then we compare the estimation result of the full and risk sample. Further, here we in the SOP case, we do not use any attrition model. It can, for further research, it can also be helpful to introduce this attrition model. No stability model covariate, and the bias are obtained by subtracting full minus risk sample, and then you will expect a fadeaway effect. And you see, this is the response probability in the start of the survey, like log hourly wages 1984, and you see that on y-axis we have a response probability. Those who are less satisfied provide less responses, and those who are more satisfied provide more responses. But the average response rate is 70%. Similarly, this is the cross-sectional OLS estimator, and you see the effect of intercept is 35%, and it reduces step by step with passage of panel wave. And you see the effect of single, it is something like 13%, and it reduces step by step, and then it remains stable after 6 wave, because those who are single, they become married, and then the distribution remains stable. Similarly, for other labor market variables, this firm sizes, they are reduced step by step, and you see that for age, tenure, and education, there is effect is almost negligible, because these variables are not changing so much over time. So we expect that the fadeaway effect is higher if we have a variable which is changing over time. Otherwise, we would not expect a reduction in bias. There will be no initial non-response bias. So here for age, year of education, and tenure, there is no initial non-response bias. So this variable is of no interest. Similarly, we compare the estimation result by some this box plot design, and you see
सर जी
this is
आपकी
the
आवाज बहुत ऐसा ऐसा आ रही है
شاید انٹرنیٹ کا کوئی ایشو ہو. اب آ رہی ہے؟
یہ سر آواز آ تو رہی ہے لیکن بہت آہستہ آہستہ ہے سر جی.
پلیز آپ کنٹینیو کریں. پلیز ڈاکٹر صاحب، ڈاکٹر مصطفیٰ آپ کنٹینیو کریں پلیز.
جی ٹھیک ہے.
بہت
تو یہ
اچھی
آپ لوگ
آواز
دیکھ رہے ہیں ہمارے پاس میں باکس پلاٹ کے تھرو بھی ان کو کلیئر کرنے کی کوشش کی. آپ لوگ دیکھ لیفٹ سائڈ پہ ہمارے پاس انٹرسیپٹ، آپ لوگ دیکھ رہے ہیں کہ یہ جو انٹرسیپٹ ڈفرینس آپ کو فل اینگلس آپ کو ہمارے پاس انیشیلی جو آپ لوگ دیکھ رہے ہیں 40% ویریشن ہے، اور آپ لوگ دیکھ رہے ہیں 1 by 1 یہ جو ہے نا یہ ویریشن کم ہو رہی ہے. اور یہ آپ لوگ جو ریڈ لائن آپ کو نظر آ رہی ہے کراس کلوزسٹ ٹو دس ریڈ لائن بائس، بٹ پھر بھی یہ ضروری نہیں کراس کرے کیونکہ پھر ہمارے پاس پرماننٹ کمپوننٹ آ جاتے ہیں، اور پھر وہ اگر ہم رائٹ ماڈل اپلائی نہیں کریں گے تو آلویز there will be some kind of permanent bias present. So یہ وہ permanent bias کو شو کر رہا ہوتا ہے. آپ لوگ دیکھ رہے رائٹ سائڈ پہ آپ لوگوں کو ایئر آف ایجوکیشن کا گراف نظر آئے گا، تو یہ دیکھیں اس کا افیکٹ بھی کم ہو رہا ہے. سملرلی آپ لوگ لیفٹ سائڈ پہ آپ لوگ جو بلاکس پلاٹ نظر آ رہا ہے یہ میل کے لیے، چونکہ بتایا کہ یہ جو ہمارے پاس یہ جینڈر ہے یہ چینج نہیں ہوتا، تو اس لیے اس کا افیکٹ آپ لوگ آلموسٹ اسٹیبل ہی نظر آئے. اور اس کا افیکٹ جو ہے نا آپ لوگ دیکھ رہے ہیں آلموسٹ 5% ہے یا اس سے بھی کم، کیونکہ یہ تو ہے نا ہمارے پاس 22 ہی نہیں اس ویریبل میں یا چینج نہیں ہو رہا ہے ویریبل. آن دا ادر سائڈ اگر آپ لوگ یہ رائٹ سائڈ پہ جو دیکھیں فرم سائز 2000 پلس، اگر کمپنی جس میں زیادہ ورکر کام کر رہے ہیں تو اس کا امپیکٹ زیادہ ہوگا ویریبل آپ انٹرسٹ پہ. تو آپ لوگ دیکھیں 15% ہے اور یہ پھر ریڈیوس ہو رہا ہے سمتھنگ لائک 7% پہ بات چلی. تو ہم یہ ماڈل ان ویریبل پہ اپلائی کر سکتے ہیں جو زیادہ چینج ہو رہے ہیں ٹائم کے ساتھ. سملرلی اگر چونکہ ہم انکم کی بات کر رہے ہیں، اور جو انکم ہوتی ہے وہ انکم آف دا پرسن اسٹرانگلی ڈیپینڈ آن اٹس پریویس انکم. سو اگر ہم لیک ڈیپینڈنٹ ویریبل کو مطلب اگر پریویس انکم کو ماڈل میں انکلوڈ کرے ایز اے ریگریسر ایز اے انڈیپینڈنٹ ویریبل، تو اس سے بھی ماڈل پہ یا بائس پہ کافی فرق پڑے گا. اور جب ہم نے ماڈل میں لیک ویریبل کو انکلوڈ کیا تو آپ لوگ دیکھ رہے تھے کہ ہمارے پاس بیفور انٹرسیپٹ واز سمتھنگ لائک 35%، نو اٹ از بٹوین 15% اور وہ ریڈیوس ہو رہا ہے. باقی پیرامیٹر آپ لوگ دیکھ رہے ہیں فرم سائز اور سارے آپ لوگوں کو زیرو پہ کلوز نظر آ رہا ہے. یہ ایک اور ویریبل انٹروڈیوس ہو گئی لیک ریونیو ویجز، اور اس کا تھوڑا بہت افیکٹ ہے، لیکن باقی سارے ویریبل آلموسٹ اس کی جو اسٹیمیٹ ہے وہ انبائس. یہ ہمارے پاس ہے سیم یہ بھی ویریبل ہے. اور اگر ہم انورس پروبیبلٹی ویٹنگ اسٹیمیٹ یوز کرے تو بیفور ہم نے سیمولیشن میں دیکھا کہ اگر ہم جو ہم نے ویٹنگ ماڈل اپلائی کیے جو ہم نے ویٹنگ ٹیکنیک اپلائی کی ہے اس سے ماڈلس پہ کوئی فرق نہیں، الٹا نقصان ہی ہوگا، باعث کی ویلیو اور زیادہ ہو، کیونکہ ہم نے وہاں پہ 2-3 وجہ، ایک ہم نے وہاں پہ رانگ ماڈل پلیس کیا تھا. دوسری بات ہے کہ وہاں پہ ماڈل میں ایک ہی انڈیپینڈنٹ ویریبل ایکس تھا. یہاں پہ آپ لوگ دیکھ رہے ہیں ہم انکم کو ایکسپلین کر رہے ہیں، انکم کو ایکسپلین کرنے کے لیے ہمارے پاس ماڈل میں آلموسٹ کافی سارے ریلیونٹ ویریبل انکلوڈ ہے، نیور سنگل جینڈر ایئر آف ایجوکیشن. تو اس سے بھی اگر آپ لوگوں کے پاس ماڈل میں ریلیونٹ ویریبل انکلوڈ ہے تب ویٹنگ ویریبلس یا ویٹنگ انورس پروبیبلٹی ویٹنگ اسٹیمیٹ وہ ہیلپ فل ہوتا ہے. ادروائز اگر آپ لوگوں کے پاس ماڈل مس اسپیسیفائڈ ہوگا تو الٹا نقصان ملے گا. تو یہاں پہ امپیریکل ڈیٹا پہ ویٹنگ ہیلپ کر رہا ہے باعث ریڈیوس کرنے میں، لیکن سیمولیشن میں وہ الٹا ویلیو زیادہ ہو رہی ہے. تو ہمیں یا تو ادھر زیادہ ریلیٹڈ ماڈلس ویریبل انکلوڈ کرنے چاہیے یا ہمیں ریلیونٹ ویریبلس ریلیونٹ رسپانس ماڈل کو یوز کرنا چاہیے. سملرلی یہ فائنل ماڈل ہے، یہ رینڈم افیکٹس ماڈل اسٹیمیٹر ہے، اور اس کا بھی ہم نے افیکٹ ہے سیم فار سیمولیشن اسٹڈی یہ بھی ہولڈ کر رہا ہے. یہ ہمارے پاس ود ان اسٹیمیٹر ہے، آپ لوگ دیکھ رہے ہیں ود ان اسٹیمیٹر یہاں پہ بھی اچھے ریزلٹس دے رہا ہے. اور یہاں پہ ہمارے پاس یہ ایک اور رینڈم افیکٹس ماڈل ہے اور آٹو کو ریلیٹڈ ہے. اگر اس کے رینڈم افیکٹس ماڈل وتھ کو ریلیٹڈ ایررس، سو اگر ہم ویٹنگ اپلائی کریں یہاں پہ بھی ہمارے پاس آلموسٹ بائس از کلوز ٹو 0. اور اس کے بعد کنکلوژن ہے کہ جس طرح میں نے بتایا کہ ہم ایکسپیکٹ کرتے ہیں کہ ہمارے پاس ویریبلس لیبر مارکیٹ ویریبلس ہو تو ان پہ ہم ایکسپیکٹ کر رہے ہیں کہ باعث کی ویلیو کم ہوگی. اگر ہمارے پاس ویریبل ہو ایج ایئر آف ایجوکیشن یا جینڈر سے یا فیملی اسٹیٹس سے تو اس پہ ہم زیادہ ہم وہاں سے زیادہ ایکسپیکٹ نہیں کر رہے کہ باعث کی ویلیو کم ہوگی، یا تو انیشیل باعث کی ویلیو آلریڈی کم ہوتی ہے اور یا ہمارے پاس وہ اس کا جو افیکٹ ہوتا ہے وہ کانسٹنٹ رہتا ہے. اس کے علاوہ ہم نے دیکھا کہ اگر ہم رائٹ ماڈل یوز کریں جس طرح ہم نے ود ان اسٹیمیٹر یوز کیا کہ اگر ہمارے پاس پرماننٹ کمپوننٹ پریزنٹ ہو تو اس کا جو ڈسٹورٹنگ افیکٹ ہوتا ہے ویریبل آربیٹرس پہ وہ کانسٹنٹ رہتا ہے. لیکن اگر ہم رائٹ ماڈل یوز کریں گے تو اس پرماننٹ بائس کو ہم کم کر سکتے ہیں بائی یوزنگ دس ود ان اسٹیمیٹر. تو یہ ود ان اسٹیمیٹر زیادہ بینیفیشیل ہے ان ریڈیوسنگ دا بائس. اور اس طرح یہ فردر ریسرچ ہے کہ ہم اس کو اٹریشن سیمولیشن جو سیکیو ڈیٹا اس میں اٹریشن ماڈل بھی انٹروڈیوس کرا سکتے ہیں. ہم نان لینئر ماڈل پہ بھی جا سکتے ہیں اگر ہمارے پاس آرڈینل ڈیٹا 0 1 2 3 ایکسیٹرا. فار ایگزامپل ہم سیٹسفیکشن اسکور کی طرف جا سکتے ہیں. ہم الٹرنیٹیو اسٹیمیٹر ہم امپوٹیشن اینڈ ویٹنگ کی طرف بھی جا سکتے ہیں. اس طرح ہم فردر جا سکتے ہیں اگر ہم رسپونڈنٹ کو شیورٹی دلائے کہ آپ رسپانس دیں آپ کی پرائیویسی سیکرٹ رہے گی. اس طرح کے لوگ پھر زیادہ رسپانس کرتے. اس طرح یہ اسٹارٹ ہم نے کیا اور اس پہ آلموسٹ مطلب کام ہوا نہیں. آپ کو 2-3 پیپر ہی ہمارے ملیں گے, اس کے علاوہ کوئی لٹریچر ہے ہی نہیں. تو یہ کافی انٹرسٹنگ آئیڈیا ہے اگر اسٹوڈنٹ اس پہ کام کرنا چاہے تو اس طرح کے ہیں. تھینک یو ویری مچ. اگر کوئی کوشچن ہے تو بتا دیں.
Thank you, Dr. Any question? Audience, please. Any question? کسی کا بھی کوئی کوشچن ہے کسی آڈین کا تو آپ کو ڈاکٹر صاحب سے پوچھ سکتے ہیں. Thanks a lot, Dr. Musa, thanks for delivering the very informative lectures on the subject. I would like to thank all the participants for their participation. Thank you so much. Thank you so much.
اوکے سر, اگر کوئی کوشچن نہیں ہے تو پھر تھینک یو ویری مچ فار اٹینڈنگ دس پریزنٹیشن.
Thank you so much. Thank you so much.
اوکے اللہ حافظ.
Allah.